Let's talk about the construction phase and what it really includes. We're often presented with a Gantt chart, right? Everyone in this room has seen these charts. Whether it's an offshore platform, an FPSO, a modularized plant, or an in-situ construction project. This is the go-to representation. But I have a concern. These charts don't reflect reality. They're too neat, too linear. EPCs typically follow the FEL framework, starting from FEED to develop execution plans, define constraints, estimate quantities, and lay out subcontracting strategies. And yet, somehow, construction remains underrepresented in this early planning. It's treated as the final step, rather than an integral part of the process from the beginning. Back when I worked at Technip, I had the privilege to be part of an incredible corporate group called the Construction Methods Center. That team gathered decades of project experience, lessons learned, and feedback from the field. Together, we engineered new ways of thinking, construction engineering that directly supported execution. That experience shaped how I think today. It's the foundation of how Konnect XD was built. When construction is brought into the conversation early, during FEED or even pre-FEED, we open up possibilities. Preliminary construction studies like heavy lifting, access and scaffolding plans, constructability reviews, and a proper analysis of the construction schedule. This allows us to create plans where man-hours are not just accurate, but adequate. But here's the challenge. Our estimates are often based on outdated indices, Excel files floating around uncontrolled, and fragmented historical data. These early concepts somehow evolve into the official project plan, the schedule, the cost estimate, even though they're not always well-founded, and we assume there will be a clean handover between FEED and EPC. Spoiler alert, there usually isn't. Let's touch on software. And no, not just mine. Aveva, for example, fantastic platform. I know some of you in the room probably use it. The thing is, software alone isn't the issue. It's the constraints we face in trying to be lean and standardized, yet flexible enough to meet evolving project needs. Organizations are doing their best. You've got brilliant people inside EPCs and owner-operator teams working across multiple disconnected tools. 4 different platforms, one common goal. They work tirelessly to produce and deliver, even if it's siloed. But here's the catch. You, the owners and operators, have critical decisions to make. You're asked to choose between Aveva and Hexagon Smart Plant suites, not just for design, but for digital continuity throughout asset life cycles. Some of you use both, legacy on one hand, strategic direction on the other. Meanwhile, EPCs are expected to support both ecosystems, building and maintaining business processes that work across them. And those processes, they're constantly evolving. The first iteration is never perfect, is it? So, at the very start of the project, what I call the red triangle, things are already noisy. That brings me to this next slide. You've all seen the standard EPC Gantt chart, but I want to show you a different Gantt, one that actually reflects what happens. Look closely. Each line, engineering, procurement, construction, tells a deeper story. Engineering spans far longer than you'd expect. It grows in complexity and effort over time. That thin little bar for construction you often see, it barely scratches the surface of the real work being done. I couldn't fit it into one bar. I had to split it into layers. Procurement starts early, especially with long lead items. It drags on, often with delays. By the time we reach 90% engineering, revisions are still coming in. I've seen projects where the number of post-IFC revisions made you wonder if we'd ever hit the finish line. We have a broken model, and that's exactly what the next slides explore. But before we go there, please understand this. Construction isn't just construction. In fact, constructors are responsible for transforming the engineering model into something buildable, fabrication grade. They take that 3D model and break it down into actual spools, actual welds, real piece marks, steel structures. They make the abstract real. Yet, these teams are often left without critical early information. They can't fully plan fabrication or foundations in time. This manufacturing phase, the transition between procurement and installation, is one of the most underrated in the whole EPC lifecycle. It deserves more attention. It is made of several workstations in itself. And I'll talk more about that concept later. Here's what I've learned over time. Construction people have a mindset. They act on instinct, not just paperwork. They anticipate. They prepare. They want to plan ahead, maximize the use of their workstations, fabrication shops, paint shop, scaffoldings, cranes, everything. But here's the twist. Yards don't belong to EPC's companies. They don't belong to owner-operator either. Yards are operating companies, and they might be juggling 2, 3, sometimes 4 projects at once. And construction yards have real capacity constraints, and planning has to be precise. Finally, pre-commissioning and commissioning don't show up at the end. They're involved far earlier than the previous chart suggests. They're gathering P&IDs, preparing loop checks, building an understanding of systems, and making sure everything is ready from mechanical completion to energizing systems. If you haven't already, I encourage you to look up a talk by Paul Turner from a few weeks back. It's on LinkedIn, and it's absolutely worth your time. Let me close this section with a key observation. We're now seeing more and more 3D models in the feed phase, and that's a good sign. The industry is moving toward automation, better data, and improved model maturity. This leads to better estimating, more accurate schedules, and a deeper understanding of the scope of work. This curve here, the 90% model review point, is critical. That's where many assumptions get locked in. But with better integration between disciplines, improved collaboration, and a real focus on data, not just documents, we can dramatically improve what happens downstream. And that's what I'll show you next. Let me show you something. This is a snapshot from 2 different moments, 100% feed on the left and 90% EPC model review, 18 months later on the right. I dug these images out of an old presentation. I used to call this slide, "Where's Wally?" or "Où est Charlie?" for my French-speaking friends. Why? Because trying to make sense of these models during execution feels exactly like that. Hunting for the truth in a sea of cluttered, outdated data. At feed, we use assumptions. Piping classes, equipment sizes, layouts, all just close enough to support a cost estimate and a schedule. But when execution kicks off, we treat these placeholders like gospel, and the gap between what was planned and what is now being built only widens. This is where construction starts to struggle. They're trying to get ahead to plan fabrication and foundations, but they don't have the information. Engineering hasn't reached the maturity level required to give reliable answers. And let's not forget the classic influence versus cost curve. You know the one. Early in the project, during FL2 and FL3, we have maximum influence and minimal cost impact. But by the time EPC is awarded, that red triangle you see on the chart, changes become painful. Everything's running in parallel. You issue IFC drawings and 5 revisions follow. The reality is, we're building billion-dollar assets using analog processes. And once changes start flying, it's chaos, unless you have traceability. That's why I believe we need dynamic baselining. Not static plans built on frozen assumptions, but live, traceable data that evolves with the project. That's how we get more value from feed, by using it as a digital foundation, not just a static milestone. This is where we get to the heart of the issue. Our execution model is fundamentally broken. It assumes clean transitions, from feed to EPC, from engineering to construction, from one phase to the next, as if projects follow a straight line. But they don't. They loop, they iterate, they evolve. And yet, the systems we use are built around documents, gates, and milestones. Not data. Let me show you something. On this slide, I've overlaid the FEL stages most of us know well, with the BIM stages, which some of us might be less familiar with. BIM, Building Information Modeling, comes from the architectural world, and it introduces a maturity framework, from basic geometry, LOD 100, to fabrication-ready models, LOD 400+. Interestingly, around our 90% model review in EPC, where we're just issuing construction drawings, BIM has already reached what they call LOD 400. That means the model is already fabricatable and installable. It's construction grade. And here's what's fascinating. When BIM first emerged, all the way back in 1979 from German researchers, it wasn't just about modeling. The very first paper was titled Construction Management, Database Driven. From the beginning, BIM was rooted in data-centric thinking. BIM came with strong methodologies. It required object libraries, catalogs, metadata standards, and more importantly, a collaborative framework between disciplines. It created space for VDC groups, virtual design and construction, where engineering and planning were deeply intertwined. Now compare that to our side of the industry. We've adopted AWP, Advanced Work Packaging, which is a powerful framework. But there's a key difference. In architecture and BIM-driven industries, designers have creative freedom, but also strong standards for how information is structured. In our world, oil and gas, heavy industrial, we're guided by strict process engineering, material specs, and piping classes. We have the libraries, we have the data structures. But here's the problem. We don't design for the next consumer. Engineering still builds the 3D model for themselves. Not for fabrication, not for construction, not for commissioning, and definitely not for operations. Only recently, with initiatives like CFE-HOS, owners and operators have started requiring structured, usable data models that can support the full asset lifecycle, not just a static handover. This disconnect between what's designed and what's needed downstream is where misalignment begins. And that's what we need to fix. Here's another real challenge we're facing in 2025. This slide comes straight from an actual tender request I saw recently. An owner-operator asked for an enterprise information management (EIM) system, as if it were just another box in the architecture diagram. What's fascinating is, this box has no name, no vendor logo, no clear definition. It's the black box of the decade. Everyone agrees it's important, but no one can fully explain what it is. It's meant to be the single source of truth. It's meant to control the data, ensure traceability, enable automation, enhance quality, and make data available throughout the life cycle. It's the system of systems, the one ring to rule them all. And yet, when you look closer, you realize something. No one really knows what it looks like. No one knows where it starts and where it ends. No single software can deliver it all. That said, it's not just a wish list anymore. This is no longer a nice to have. It's an expectation. Owners and operators are pushing for this level of integration, and rightly so. They want confidence in their data and continuity across the lifecycle. They want handover packages that aren't just PDFs in a folder, but usable, searchable, structured information. EPCs are adapting, slowly but surely. Many are deploying powerful tools, like Aveva Engineering among others, to try and meet parts of this challenge. But let's be honest, this is still a fragmented ecosystem. There's no magic solution. But what's clear is that data integration is now core to project delivery, and the demand from owners is only going to grow stronger.